Hello, everyone, and welcome to today's webinar, Understanding Fire in the Forest, a part of our field report series here at Columbia Land Trust. My name is David. I'm part of the team at Columbia Land Trust, and I'm joined by Lindsay, a key leader of our stewardship team in White Salmon, Washington. Today, we're going to look at sharing the story of fire in these Cascades. It's a history and how we're leveraging partnerships to reintroduce good fire back into our forests. Before we dive into the presentation, just a couple of housekeeping notes. This webinar is being recorded and will be available on our YouTube channel. We'll also email you a link once it's ready. Throughout the session, you're welcome to submit your questions using the Q&A module. After the presentation, we'll have time to answer a few of them live. We'd like to first extend a heartfelt thank you to our sponsors who helped make this webinar series possible. Our lead sponsors this year are Vista Capital, First Pacific Financial, the Confederated Tribes of Grand Ronde, Killing Pacific, and Becker Capital. And our supporting sponsors are Columbia Bank, PR Worth, Schwabe Williamson and Wyatt, Interfluve, Northwest Natural, and Trillium Asset Management. Before I turn it over to Lindsay, I'd like to share a quick introduction to Columbia Land Trust for those who are new. We live in one of the most extraordinary regions in the world. From the coast to the East Cascades, there are few places like it that offer such a rich diversity in landscapes, wildlife, and plants. That's why we're here. Our mission is to conserve and care for these lands, not just for today, but so future generations continue to experience that deep, powerful connection to nature. But we also know we can't do this alone, so our work is built in collaboration. We partner with farmers, with tribes, with foresters, and local communities, because together we can accomplish so much more with lasting shared outcomes. Now, I'd like to introduce Lindsay. Amazingly, Lindsay started at the Land Trust when she was just 12 years old, volunteering with her dad, who was a founding board member. She rejoined the Land Trust after college and now has been working with us for over 20 years. In her current role, she supports the East Cascades Oak Partnership, which aims to advance conservation strategies in the East Cascades around the Oregon white oak. She also leads our stewardship efforts in the East Cascades, a place where fire was and continues to be a part of this landscape story. Lindsay?
Thanks, David, and good afternoon, everyone. Thanks for joining. I'm Lindsay, and I actually wanted to start today by reflecting just for a moment on my personal relationship with fire, and I'm encouraging you to do the same thing. Fire is an inherently useful thing. In various forms, it warms and cooks and powers and enlivens our lives. It serves as a primary heat source in my house. It propels my car down the road. It erases my yard debris. It's burned my skin and singed my eyebrows, and it saved my life on more than one occasion. It's also the main attraction on our family camping trips and gatherings with friends. It literally draws the people I love together to share food and music and stories, as I imagine it has since prehistoric people first harnessed the sparks that changed the course of human history. But of course, fire is also a force of nature. And just like water sustains and devastates us, so does fire. I live just outside White Salmon, Washington, where this summer my family was evacuated, and not for the first time, for a wildfire. The Burdoin fire and recent fires in Rowena and Mosier on the Oregon side, like the one in this video, ended up destroying dozens of homes in the gorge. And many people have significant trauma around fire. They have run for their lives, or lost family members, or friends, or pets, or homes, or other special places to fire. And this presentation is in no way meant to diminish those losses or to suggest that they don't warrant every protection possible. But I do mean to shine a light on our relationship with fire and on the responsibility we have to ourselves and to these fire-adapted forests and the plants and wildlife that rely on them to prepare for and even welcome healthy, safer fire into our lives. So we live in a phenomenal landscape, where as you move through the Columbia River Gorge, you travel from conifer-dominated forests to oak and pine woodlands to shrub steppe and grasslands over a very short distance. And fire interacts with and shapes each of these places in different ways. And as you might imagine, vegetation is lush and well hydrated, where precipitation is robust, and these types of forests resist fire except in the most extreme of circumstances. So forests like this will typically only burn on average every 200 to 500 years. While a forest like this one, where precipitation is sparse and summer droughts are extensive and temperatures are more extreme, a forest like this will support more frequent fire, on average every 5 to 30 years. I live in a forest like this, and it is in that wildland urban interface, the place where forests and homes are interspersed, that Columbia Land Trust manages more than 11,000 acres of protected habitat in the East Cascades. And we expect that figure to double in the next 5 years as we execute more land protection projects. So what do I mean by fire-adapted forest? Fire-adapted forests, or frequent fire forests, are shaped by climate and vegetation conditions that support frequent fire. The plants and animals that occupy these types of forests have life histories that are also adapted to the presence of fire. So ponderosa pine, for example, drops a third of its needles every year, building a fuel bed at its feet to carry a low intensity fire on the regular. And these fires remove all the low hanging branches. It creates more space between the forest floor and the lowest live limb of the tree. And that prevents subsequent fire from climbing up or laddering into the canopy of the forest. Pines also have thick bark that insulate the buds from and the cambium from damage to fire, and they also increase the production of pitch in response to fire. That helps the tree resist attacks by wood-boring insects like the western pine beetle. So fire is also an important part of tree health for ponderosa pine. Oregon white oak also has very thick bark and waxy leaves that resist burning, and they can sprout back from the buds in their root collars if the crown is damaged or consumed by fire. There's even lots of species of wildflowers and grasses are adapted to fire, resprouting from the roots or responding from seed when they're burned. So, how can we know how frequently fires burned in these forests? Tribal elders hold knowledge about cultural burning practices that promote roots and berries that are favored by fire and used by people as foods and medicines. And scientists can interpret the scars that are embedded in growth rings on old snags to not only count the frequency of fire events, but to date them. This particular study was conducted by Dr. Andrew Merschel at Oregon State University on the east side of the Mountain Hood National Forest, where the oak and pine forests are. And his study showed how fires burned at warm, dry sites on average every 7 to 12 years prior to the 1900s. And you can see each yellow line on the chart represents a sampled tree or snag, and the red triangles along those lines represent fire scars. And not every fire event will leave a scar on every tree, so the samples actually underrepresent the frequency of fire. There's a super recorder tree, the last line on the bottom of the chart. That tree established in the mid 1940s. It lived 400 years and it experienced more than 30 fires in its lifetime. So, what did these fire adapted forests look like? For one, they were variable. So, depending on soil type and elevation and aspect and when they last burned, they might have been dominated by Oregon white oak or by Douglas fir or by ponderosa pine, like the woodland that's pictured here. Some had more shrubs than others. Most had a variety of wildflowers and bunch grasses or sedges, scattered large snags, but almost always they are characterized by old, mature, fire-resistant trees that were widely spaced or in clumps with big openings and gaps where snowfall met the ground and sun-loving species proliferate, and there's smaller clumps of younger trees regenerating following fire. And what's very noticeable when we look at these fire histories all across the American West is that fires abruptly cease in the early 1900s. This is a short time after the Wars of 1855, which forcibly removed Indigenous people to reservations, that severed lifeways that shaped this landscape prior to colonization. It also represents a shift in how people and economies were organized. We built permanent residences like my house that require protection, and we commodified forests and grasslands for agriculture and timber. And these represented investments that people don't wish to see go up in smoke. So, to better protect those investments and to protect people from harm and from loss, we built a robust fire suppression system that today spends between $3 and $4 billion annually to put fires out. But as climate change and changes in forest conditions and forest health conspire to fuel more severe wildfire, we see that these investments just aren't enough. Despite all sorts of advancements in technology and strategy, we can't seem to put fires out fast enough, and tragedy after tragedy unfold. And meanwhile, the forests are telling us what we can't seem to hear, and that is that we need to learn to live with fire. Fire is inevitable. We need to harden our homes. We need to prepare our forests. And all fire is certainly not created equal, and I believe we can recover our relationship with fire, and we can adapt our lifestyles and our homes and our lifeways to make room for it, and we can calm it down. So, what does a fire-suppressed frequent fire forest look like? It looks more like this. There are still old, mature, fire-resistant trees where they haven't been harvested or cut down, but they're now surrounded by smaller, very dense trees, often shade-tolerant species like Douglas fir or grand fir that would have been less prolific in this landscape because they aren't as fire-adapted as pine and oak, for example. The fuels in these stand conditions are connected both vertically and horizontally, and they're able to carry fire more rapidly through the forest. And the quantity of accumulated fuel generates more heat. So this combination of things can lead to stand replacing fires, the kind of fires where what remain are just ashes. And unfortunately, climate change predictions suggest that these trends will only intensify. With warming temperatures and longer periods of drought and less snowpack and increasing storms, we can expect our forests to face increased risk of drought stress. Plants have to make choices when the air is dry. When they open their stomata, those are the little holes on the surface of leaves or needles that allow the plant to absorb carbon dioxide for photosynthesis, they lose water to the air. And when the air is very dry, they lose a lot of water. And at some point, trees just won't open their stomata to prevent water loss. And when this happens for long periods of time, or especially year after year, they start to starve. Or they'll open their stomata anyway in order to make food. And the pressure inside the xylem cells, those are the cells that convey water from the roots to the leaves, the pressure in those cells becomes so great, and the difference between the supply of water in the soil and the demand from the air is so extreme that the cells collapse under that pressure. They cavitate, and that kills the part of the plant above the cavitation. And so these are severe signs of drought stress, and stress makes plants more vulnerable to insects. When there are a lot of dried out or dying or dead trees in the woods, the risk of fire escalates. So what can we do? What prevents us from fixing this problem? For starters, it's a huge problem. The US alone has 765 million acres of forest, and we have been actively suppressing fire on almost all of it for more than a century. In Washington state alone, the DNR has mapped 2.7 million acres of forest land in need of treatment in central and eastern Washington, identifying Columbia Land Trust service area in Clicktack County as one of the highest priorities in the state for forest health treatments. So this prioritization helps Columbia Land Trust secure some of the resources we need to thin our forest stands and remove accumulated fuels in preparation for fire, with a long-term goal of returning forests that look like this into forests that look like this. Now, this transformation takes both effort and time. And so we either have to lower the density of the trees using mechanical interventions like hand falling trees with chainsaws and then piling and burning the wood, or masticating or cutting trees using mechanized logging systems like feller bunchers or masticators. And these treatments can be designed to minimize disturbance to soils and plants in the understory. But the treatments inevitably create a disturbance in and of themselves. I see that as a necessary disturbance to reset these stands on a more sustainable and healthy path. And we have practices like only operating machinery when soils are dry or frozen, pile burning to remove slash, seeding to make sure that the stand is on the right track when we're finished with our restoration. We also do a lot of monitoring to better understand the impacts we're having, both positive and negative. There was a recent academic paper, the lead author was Kim Davis, that analyzed dozens of restoration projects across the American West to better understand the effects of thinning and burning on subsequent wildfire. And the result showed that thinning did lower the risk of catastrophic wildfire. That thinning paired with burning, either piling the material that was cut and then burning it, as shown in the photo on the left, or broadcast burning in the understory, as shown on the right. It's when you just light the entire forest floor on fire. That treatments that incorporated some element of fire, pile burning or broadcast burning, had the most positive effect on subsequent wildfire outcomes. And the difference was compelling. It was a 30% reduction in undesirable wildfire effects due to thinning alone. But when you paired it with burning of one of these types, it experienced a 60 to 70% reduction in undesirable fire effects following a wildfire. And you can see that demonstrated in this photo from the Bootleg fire in Oregon as well. So the forest that was thinned and burned in the center of the image fared much, much better than the forest that was thinned only on the bottom, and the forest that received no treatment at all on the top. So why does burning matter so much in returning fire-adapted forests to a fire-ready state? We already learned how some plants are adapted to fire and they benefit from it physiologically and reproductively, but also the surface fuels that accumulate on the forest floor. This is the duff and litter, the dead needles and leaves and sticks and down wood. They can generate a surprising amount of heat when they burn. So even if the trees don't literally go up in flames, the heat damage or the scorch from accumulated fuels on the forest floor can still kill mature trees. And this is what happened in the thin only areas of this photograph. But the good news is that controlled or prescribed burns can safely remove those surface fuels. So what is prescribed fire? Prescribed fires are when we intentionally light a fire in the forest to accomplish a specific outcome. And we can adjust things like the timing of the fire and the duration of the fire, our ignition patterns, how much fuel is available to impact the outcomes of a controlled burn. So let's walk through what a prescribed burn might look like. First, we prep the unit. So that usually involves digging control lines or contingency lines around the area we want to burn. We'll remove excess fuels, especially around important resources like large legacy trees or snags that we don't want to burn, or along the control lines to reduce the chance the fire might cross the line. We install monitoring plots so we can observe and measure changes that happen following a burn, because some fire effects you see right away and others take years to manifest. So we like to have a formal way to track those changes. And we use what we learn on each burn to inform subsequent burn plans. And those burn plans outline the parameters that we think will maximize the desired outcomes and minimize undesired outcomes like escapes. So the parameters include variables like relative humidity, how moist or dry the air is, the wind speed or direction that we might want to see in a burn day, air temperature, how dry the fuels are. And so we define those variables based also on the fuels present. Are the fuels light fuels that will combust readily and burn out quickly? Or are they heavier fuels that will generate more heat for longer? How connected are the fuels? How deep or heavy are the fuels? So we make a plan, and that plan also includes notifying neighbors and agencies that respond to emergency calls so that everyone has the information they need to feel safe. And we get permits. And on burn day, we go through a whole series of checklists, making sure we have the equipment and personnel needed to safely undertake fire. On our burns, we rely on expertise and crew and equipment support from our partner, Mount Adams Resource Stewards. They're a nonprofit that's in our region working to make fire more accessible to private landowners. And we also rely on partners from the Forest Service and from the DNR and from local fire departments and even our volunteers, especially while we're learning this relatively new management tool. So preparations on burn day involve deploying hose lines and fire trucks, hand tools and backpack sprayers and water tanks. We make sure people have protective gear on and they understand their roles. and we make sure emergency plans are in place. And when we're ready to go, when weather conditions are right, we start a test fire. And the test fire is usually done in an area that's easy to extinguish if needed. And the burn leaders will watch how the fire behaves to determine if we should continue or if we should stop. Prescribed burns do generate smoke. And to some extent, we can actually manipulate the smoke column to make it stand up or to push it one direction or the other using different firing patterns. But in the end, wind is wind. And at the end of the day, the smoke will settle as the air cools. And the fire, depending on how much heavy fuel was in the unit, might smolder for several days. So smoke is one of the chief complaints against prescribed burns because it impacts people's health and it can obscure visibility on roads and it can taint sensitive crops like grapes or other fruits. But the good news about prescribed fire smoke is it's far less impactful than wildfire smoke, both in terms of quantity and duration, and it can be predicted. So people can be moved out of harm's way, crops can be harvested or protected, and the smoke signals that if you are close enough to smell the smoke of a prescribed burn, you're close enough to reap the benefits if wildfire comes knocking. So while the burn is happening, people are doing their jobs. The burn boss is bossing, the ignitions crew is lighting, the holding crew, those are the people with shovels and Pulaskis and backpack sprayers and hoses. They're ensuring that the fire doesn't leave the perimeter of the burn unit. This video will give you an idea of what you can expect to hear on radios that crews are using to communicate with each other during the fire.
Is going to help pull their fire activity back interior and minimize that. So they're going to slow a little bit or let you guys get ahead of 50 to 100 feet. Get your heat established interior and then we'll have things sucking in. So you guys keeping your heat going but at a nice, consistent, moderate pace I think is going to be important to smooth operations. I copy very much.
All right, so in that clip, you can hear the burn boss giving direction to the ignitions team, and they're manipulating what's happening in the interior of the burn unit. One of the cool things about fire is its variability. So you get a gust of wind here, or a pile of fuel there, or a resistant plant here, a meddlesome person over there, and you get places within the fire perimeter that don't burn. And this is a similar pattern of variability that you might observe in wildfires when one home burns and one nearby doesn't. And in a far less tragic way, that variability is what makes our habitats more complex and interesting with like these little islands of difference that support more species richness. So we don't expect a burn unit, and indeed we don't want a burn unit to come out looking uniform and perfect. So let's see what these fires look like when they're burning. You can see in this case the flames are quite small and they're moving pretty slowly. And you might expect this fire to behave a little bit differently when it reaches that small fir tree or the ceanothus bushes. But for the most part, it's just kind of creeping along. And then here's one that's just a little bit spicier. There's a little more wind. The flames are a little taller, but you can still see the fires clearly moving away from the control line, establishing what's called a black line, which improves the defensibility of the control lines. This photo and this video show a phenomenon known as torching. So every now and then, due to a concentration of fuels below a tree or a particularly thick crown or a pitch seam that runs up the stem of a tree will torch. And that means the entire crown goes up in flames. And these are most often Douglas fir trees. They're less fire resistant than ponderosa pine. They have dense branch structure, captures more heat, it carries flame more effectively up the tree. So when torching happens, it gets everyone's attention. You can hear it, you can see it typically. And under most prescribed burn conditions, which are wetter and cooler and way less windy than most wildfire conditions, the close neighbors of a torching tree might be affected, but the fire doesn't typically spread through the canopy. The torching lasts a minute or so and then it dies back down. So mostly it's just a good show, and when this is a good signal for the holding crew to watch for embers that could drift down and across the holding lines because the fire's moved up in the profile of the canopy. After ignitions are done, efforts transition to mopping up. So you let the fuels in the interior of the unit burn, sometimes for days while you patrol the fire, but you extinguish any burning material on the perimeter. And this helps prevent something from flaring up and lighting unburned material on the other side of the holding line. And then for us science nerds, the fun stuff starts. You get to see how wildlife and plants respond to the fire. Some species of beetles and wasps show up almost immediately following a fire, like while you're in mop-up, and the birds follow. And you'll start to see which trees scorched, how much the crown heights might change. It's indicated by the scorching of the trees, the brown needles, which will eventually fall off. Parasitic mistletoe will fall dead from the treetops. Fire has a sort of cleansing effect on the tree crowns. Seedlings that would have created additional competition stress as they matured have died. Grass thatches have been consumed. Shrubs will have been singed or killed. And as time goes on, you'll see which trees are going to pull through. By design, fire is used to thin the forest or reduce the number of live trees that are growing on the site. And we call this a thermal thin. And when they die and topple over, they'll be burned in the next prescribed burn a few years later. Plants will sprout up in the understory, sometimes just days or weeks later, depending on the timing of the burn. And the forest will essentially be on a path to recovery. In this photo, 6 weeks after a spring burn, the control line runs straight up the middle of the photograph, and the unburned is on the right, and the burned is on the left. And one could argue that the stand on the right is prettier. It's greener, and that might be the case for now. But as those dead ponderosa pine saplings that you can see in the background topple to the forest floor and the understory plants continue to develop, the forage for wildlife becomes more attractive and palatable because the old woody stems have been replaced by fresher material. The leaves are laden with nutrients from the fire. And someday, when another fire burns through during a hot summer month, the forest that was burned will show better resistance to catastrophic fire behavior than the forest that wasn't. And the tables will turn on which side of that line is greener. And that's when you start to understand the benefits of fire at a landscape scale over long time horizons. These photos are of a burn site we manage with a lot of tree squirrel nests. And so we have special monitoring in place, and we go to great effort to prevent oaks from burning in these places. Squirrels use oaks for natal dens. We also do a unit at a time, ensuring that we aren't overwhelming an entire population with a single stress event. We're partnered with WDFW and Oregon State University researchers and others to understand how plants and wildlife respond to these fires. We are also monitoring for the effects of fire on the spread of undesirable annual grasses. So these are aggressive grasses that displace the native perennial bunch grasses. Bunch grasses grow in clumps, as their name suggests. And the annual grasses fill in the space between those bunch grasses where wildflowers establish and where bees and other organisms nest in the bare dirt. And so these grasses, these annual grasses, have proliferated across the West, mostly due to spring grazing practices that prevent or slow the reproduction of the native bunch grasses, and due to logging practices that disturb soils, allowing more aggressive plants to seed in. These are also sun-loving and carbon-loving plants, so climate change is expected to favor annual grasses in the future. And you may have heard about some of these. There's like cheatgrass and medusa head and ventonata. And these aren't inherently bad plants. You know, they're just unchecked in this place at this time by natural predators or ecological conditions, and they spread prolifically. So some of the consequences of that spread are that they offer less nutritious forage for livestock and wildlife. They have heavy silica content, so it's not a material that's very useful to wildlife. They carry fire faster because of how they grow in these dense mats and because they die back earlier in the year than native perennial grasses do. They also have really shallow root systems compared to the perennial grass systems, which have 4 to 5 foot deep roots. And that changes nutrient and water cycles and affects soil health. And because annual grasses displace other plants, they prevent seed soil contact and establishment of other types of plants. They contribute to a general decline in biodiversity. So we don't want grasses, these annual grasses, to respond favorably to fire. And we're learning about how the timing and severity of our prescribed burns and how post-fire practices like seeding or spraying can reduce this particular threat in our fire-adapted forest. These photos show the fire effects in an oak-dominated woodland. So the pre-burn condition is on the left, and you can see all the coarse down wood and the grass thatch that was consumed by the fire in the middle photograph, and you can see the green up the following spring. In total, we've only broadcast burned 5 burn units, somewhere around 125 acres. But we've thinned and pile burned on more than 1,000 acres to date, and we have a landscape management plan to scale up as we learn more and as we secure more resources and funding to implement this work on the thousands of acres that we own and manage. So, what can we do to accelerate the pace of treatments and get more work done? We can ask our elected officials or private foundations and donors to support grant programs and organizations that prioritize this kind of work. We can invest in land protection projects and land use planning efforts to reduce the number of new residences in the wildland-urban interface, where we might use fire to safeguard communities and habitat and working forests. In fact, Columbia Land Trust is working to permanently protect more than 75,000 acres of fire-adapted forests in the gorge as we speak, and you can learn more about how to contribute to that effort on our website. We can also engage our communities, including elders and children, in prescribed burns, so they learn about and adopt a kind of healing culture of fire in the forest. This picture is of the Mount Adams Prescribed Burn Association, which was lifted by Mount Adams resource stewards and Columbia Land Trust just a few years ago. And very few people in this photograph are professional firefighters, but all received training through the Prescribed Burn Association, or PBA for short. PBAs help people like you and I get more involved in healthy fire, and there are a few that may have formed near you. And so to connect with some of those PBAs, you can visit OSU Extension's website and just search for PBAs. They have a whole list of organizations that you can connect with. And you don't have to be a landowner, you don't have to be a firefighter to participate. You just have to want to see good fire in our forests and be able-bodied enough to stay safe while you're helping. You can also have an impact just by understanding the issues and supporting active forest management when it happens near you. Respect temporary trail closures, accept that things might be messy for a season or two. Ask questions about the prescriptions and why managers are making the choices they're making. Volunteer to help with the work. Show up and monitor. So you can learn more about dry forest just generally using some of the resources that are outlined here, which will be shared with you after this event by email. Other ways you can help: you can volunteer at your local fire district. You can be supportive of prescribed fire, even just conceptually in conversation, by accepting the inconvenience of smoke. And if a fire does get away from us, if it escapes, please help your friends and family understand that learning how to live with fire in today's radically transformed landscape is going to require some risk and a lot of learning. But the risk of prescribed fire is a great deal more manageable than living in today's landscape and doing nothing about the threat and severity of wildfire. So thank you for listening. I look forward to hearing your questions, and I'm going to give it back to David.
All right. Thank you so much, Lindsay. Yeah, it's truly fascinating to learn about the history of fire in this area and how we're reintroducing it to the landscape. We really appreciate you sharing this presentation. It looks like we have a few questions, so let's take some time to answer those now. Our first question is if you could talk a little bit about a PBA and how that's formed, and if those exist throughout the US, or is that mainly in this region?
Yeah, PBAs do exist throughout the US. They're actually exist to support agricultural operations. There's PBAs in the breadbasket where people are burning wheat fields together. There's PBAs in the southeast in the pine forest there. They're all across the nation, and they all take different shapes and sizes. They serve different purposes. And so depending on where you are and the goals of the community around fire, they can look different from PBA to PBA. The one I'm most familiar with is the one Columbia Land Trust is a part of, and that's the Mount Adams Prescribed Burn Association. And it's well supported by Mount Adams Resource Stewards, which is an organization that has crews that work in the woods that deploy fire on a regular basis. And so that expertise is really helpful in getting comfortable with fire if you're new to it. And they also have an equipment cache that they created using grant funding support that helps get people into the protective gear they need on a fire. It makes tools available like hand tools and water tanks and sprayers and that kind of thing. So a lot of different ways that PBAs can be formed, but generally just takes interested people getting together and learning about it. And the Mount Adams PBA is sponsoring over the next 3 days, actually starting today, a PBA learning exchange where they're literally supporting the efforts of other people to create new PBAs across the Northwest.
Oh, excellent. That's great. Another question, just generally asking, you spoke about this a little bit, but about the scalability of prescribed fire. What is you mentioned some of the work that Columbia Land Trust has done, and how large that has been for prescribed fire. What is the biggest known prescribed fire that you're aware of?
Ooh, gosh, I don't know. Uh, in our research, when we were trying to understand the real versus perceived risk of prescribed fire, we learned that the federal government might do fires on a much larger scale than what most private small landowners are going to accomplish, and sometimes those are on the order of 1,000 to 2,000 acres at a time. We hope that over time we can scale up in our burning activities, but the landscape needs a lot of preparation before we can get to that phase. We have a first and what we call a first entry burn, where you're really carefully introducing fire because it's been absent for so long and there's such an accumulation of fuel. So you gotta take baby steps toward creating a landscape that can receive fire in a more efficient manner at a larger scale.
That's great. Thank you. How about the proximity to communities and homes, and how close can you be to homes and communities and still use prescribed fire? Is
We have
there
seen prescribed fires deployed in people's backyards. In fact, we have a fellow on our PBA, a member of our PBA, who's also a forester, has been in industrial forest management for decades. And he deployed a prescribed burn using the support of the PBA in his backyard, just several hundred feet from his structure. I've seen pictures of other PBAs in other parts of the state burning off people's back porches. So you can get pretty close. It really comes down to your comfort level as a landowner. The landowner does carry the risk in a prescribed burn, carries the liability risk. So it's an important consideration. When we do our prescribed burns, we engineer multiple layers of protection for our neighbors. So we have multiple contingency lines. We over-resource our fires, meaning we have more resources and personnel on site than we think we actually need to safely implement fire. And then we notify. So we have a neighbor at one of our sites who has a lung condition, and we give him plenty of advance notice and support him with resources so he can leave during that time that he might be compromised. So a lot of variability in how that looks and what people's comfort levels are.
Got it. Thank you. Another question about the gear that people see personnel using during prescribed fires. So the question is, domestic firefighters wear masks and respirators, but forest firefighters do not. Is there a reason for this, as all smoke has pulmonary harm?
Yeah, there was recently an article in the New York Times about that very issue. It took until I can't remember what that article said, somewhere in the mid 70s, to put respirators on structural firefighters, and there was a lot of resistance to that. There's resistance because it encumbers your movement, it encumbers your vision. You can't breathe as well, you have to move slower. There's a lot of reasons why firefighters don't like it, but they can get used to it. And so I think wildland firefighting culture, same situation. It's very difficult to breathe. You might be on a fire line for 15 hours digging fire line. It's really hard work. In a prescribed burn application, It's a little bit different than a wildfire. There's less smoke for one, but you also can engineer breaks for your crew. So you can have a holding line that's downwind that's receiving most of the smoke, and you can give people breathing breaks. You can mask them. We can rotate through who's responsible for the holding of that line. So there's a lot of tools you can use to reduce exposure and prescribe burns that you might not have the ability to use in a wildfire.
Okay, great. Thank you. Another question that's come in. During reforestation, are trees planted to accommodate the target standards you describe?
That's a great question. So it used to be for plantation forestry, when your goal was to produce volume, you would plant in a grid. It's easier to maintain. It's predictable. You can get your planting crews very efficiently to get the plants in the ground. And then you overplant because you assume some of them are going to die. And then you have to go in and do some pre-commercial thinning in order to allow trees the room to grow as they mature. And you select for the strongest individuals that are growing the tallest and straightest. And that's kind of the traditional model of forestry. Columbia Land Trust is doing things a little bit differently. So when we do any kind of ecological forestry, we're thinking about the plant composition. So ponderosa pine doesn't get you as much money as a Douglas fir tree does at the mill. It's just softer wood. So uh, you end up with plantations that have a preference for the more valuable species. That's totally appropriate in a commercial industrialized application, but in ecological forestry, you want to think about the species that are best adapted to your site. And then you plant them in densities that you hope will mimic kind of a more historic density. And seedling stock has gotten stronger over time, and so you have more comfort that those seedlings are going to survive.
That's great. Thank you. Another question that's come in, is there a current issue with the health of the Pacific Northwest cedar trees that seem to be dying everywhere and add to the natural fire risks?
Yeah, so all trees have a range of climate conditions that they can persist in. And when they experience stress, when they're on either end of a range of tolerance, either around temperature or precipitation or soil moisture or competition, they will experience stress and that will expose them to risk to drought and pathogens, insects, those kinds of things. And so Western red cedar does seem to have a strong response to temperature and moisture. And so, where it has previously established, there might be places where it's going to no longer persist or it's going to struggle. But I wouldn't say that it is inherently more troubled than any other species. It might just have a narrower range of conditions in which it can thrive.
Okay.
So, definitely prioritizing those places is really a priority for conservation.
Okay. Thank you. Can you talk a bit more about your monitoring post-burn and if you've learned any significant lessons over time that changed how you approach a burn?
Yeah, and I would say, our burn program is really young. We did our first broadcast burn in 2023, and it takes a couple of years to see what we call the second order fire effects. So you have the effects you can observe right after a burn. How many trees did we think we killed? What was the scorch like? How much consumption of the fuels did we get in the unit? But over time, you start to see like which species bounced back and which didn't, or whether the distribution of species changed within the stand, how much fuels are accumulating post-burn due to, standing dead trees that have come down. Those are all things that we'll track over time and we'll use to calibrate our approach. But as with all monitoring of ecological systems, they're very complex, and being able to comfortably associate the outcomes you're observing with a specific aspect of your fire prescription is kind of challenging. So I think over time we'll rely on our partners' experience, on our own observations, and on the monitoring data to try to dial that in. And ultimately, management is just a forever experiment. No two systems or across the same moments or different seasons are going to respond in exactly the same way. So it just behooves us to continue being mindful of observing and learning as we go.
Right. Thank you. Um, A question about what role does prescribed grazing by ruminants play in forest fire management in the Greater Gorge area? And if, when vegetation is palatable, how can ranchers create alignment with your work?
Oh, that's a great question. We actually worked with a fellow named Tip Hudson. He's advisor at the with WSU Extension and a professor, and he has a podcast called Art of Range. Super knowledgeable. We've learned a lot from him, and what we understand is that if you can just prescriptively move your animals around, more than just deploying them in the same place at the same time for the same amount of time every spring, you can accomplish a great deal. So think about, if you have a big open range area that's 1,000 acres, if you can put your cows out in a different place each spring so that they start in different locations, that changes the timing at which the plants are cropped by the grazing. And that will promote the ability of different plants across that area to reproduce successfully. The other thing is there's all sorts of standards around stubble heights, like how much of the live plant you should graze before you really diminish its ability to recover. And so watching that and moving the animals around in response to that grazing pressure is important. Um, we have seen grazing deployed in the fall to good effect to break up dense thatches of grasses and allow more seed soil contact with the native plants. So you can deploy fall grazing to good effect, but the nutrition in plants are less available to domestic grazers during the fall than they are in the spring. That's why spring grazing is so popular because the grass is greening up, it's really nutritious, and animals really enjoy eating it. In the fall, it's a little less attractive. So there's a lot of things you can do with your grazing systems, and there's now virtual collars that you can put on your cattle and get them to move across the landscape without having to use a lot of fencing or gates or labor. So there's some new tools that are emerging that I think give us a lot more flexibility about how we can meet both the needs of ranchers and the needs of native plants in our communities.
Okay, great. Thank you. We have a few questions about just our collaboration with local tribes and how that relates to prescribed fires. Would you touch on that a bit more and just talk about how we've worked with them, um, and what that collaboration has enabled us to learn?
Yeah. So Columbia Land Trust has lands that we own and manage, and some of those lands occur in the ceded territories of the Yakama Nation and Confederate Tribes of Warm Springs and the Grand Ronde. And some of those lands are actually on reservation. So we have lands up near Glenwood, Washington that are on the Yakama Nation Indian Reservation. And we work with their tribal forestry staff and their natural resources staff to calibrate our burn plans and to leverage funding for that landscape. And we partner on implementation in that way. And so we have a long history with the Yakama Nation. We've been working with them for more than 20 years, doing large scale riparian restoration projects, and land protection projects. And so we have a great working relationship, and we feel really encouraged about our ability to work across boundaries and to enter into co-management agreements on the lands that we're managing. We also have the East Cascades Oak Partnership, which is a collaboration of more than 20 organizations, agencies, tribes, nonprofits that work together to advance our learning and share resources and leverage funding for work in our Oregon white oak and ponderosa pine woodlands. And through that collaboration, we have directed funding to the Warm Springs Reservation, to ceded lands that are important to local tribal or indigenous people. And so there's a lot of different ways that we're kind of collaborating around resources. We also endeavored to learn more through assessment on some of our restoration projects. And we have been participating in conversations with tribal elders in that regard with the Warm Springs and with Yakama Nation. And so just learning and listening is a really important part of how we understand the landscape, the history of the landscape, and the future.
Great, thank you. Um, does the Columbia Land Trust assist with the management of prescribed fires outside of our region in other parts
We
of the
haven't been, we've been sharing resources. We've share with other land trusts some of the tools that we've used to help our organization get more comfortable with prescribed fire. So it's a perceived large risk, and there's, of course, an inherent risk in fire. And so helping our organization grow comfortable with understanding that risk and then building tools and policies and procedures to help mitigate for it was an important part. And we've been sharing that learning with other land trusts. And then through the PBA, the Mount Adams PBA, we support in that way. And through the East Cascades Oak Partnership, we have a website where we share out resources with landowners about management considerations and tools and resources that people can be using to better understand and then make different management choices in the landscape. And fire is one of those.
Okay, great. Thank you. We're just going to take one last question. So this question is about, once we do a prescribed fire, we reduce fuel loads, and we feel like that forest is in a good place. Moving forward beyond that point, how much intervention do you think it will require? In a way, do you envision that there'll be natural forces and then we'll be able to take over, or will it require a constant intervention from us, from humans?
Yeah. Well, I have a dream that one day, um, I believe that with enough investment and cultural change and over a longer period of time, we can create an environment in fire adapted forests where fire could pretty safely move through wildfire. Um, I think the things that make that challenging are the defensibility of our homes. Our homes are largely made of combustible materials. There's a lot of ways that you can mitigate for that with different building materials and with landscaping, and those are called home hardening projects. I think we can do that. I think we can be thoughtful about where we build homes and where we invite fire, prescribed fire to help buffer and insulate those homes against intrusion from wildfire. I think our management plan on Columbia Land Trust protected lands looks at the cost, the initial cost of doing that first entry treatment is much higher because there's so much accumulated fuel in these forests and they need such great help in the beginning to kind of create a condition where it could receive fire and we wouldn't expect a catastrophic outcome. Maintaining that will just require, a 5 to 15 year reentry to do some light fuels reduction, piling and burning, or to do a broadcast burn. So we're really hopeful that over the long term, we can create a landscape that doesn't require quite as much investment as this first entry will require. I feel pretty hopeful about that.
Well, I love that vision. Thank you.
Mhm.
So those are all the questions we're going to have time for today. So just a quick thank you to everyone who joined us. Keep an eye out for upcoming webinars in our field report series. And if you're feeling inspired to learn more, get involved, or support our work, we'd love to hear from you. Thanks again, and we will see you next time.